perpendicular lines, their slopes are opposite reciprocals. The product of the slopes of perpendicular lines is -1. Okay, basic foundational information here. All right, so let's look at, on page 53, let's look at number 4. And the instructions are asking us to find an equation of a line that's parallel to the given line, but I would like for the new equation to go through the point 3, 2. The only thing I need from the given equation is its slope. And this equation is printed in, or is presented in slope-intercept form, so it's easy to identify that the slope is +3. So one method for finding an equation of a line that's parallel to the line y equaling 3x plus 4, here's one method for doing that. I can take my slope-intercept form of an equation, and here's the generic formula slope-intercept form of the equation. I can replace the m with the 3. The only thing I need from the given equation is its slope. And then I have a new point with an x-coordinate and a y-coordinate. So I simply replace the y with the 2, 3 is the slope, the x-coordinate is 3, and this allows me to solve for the new y-intercept. So -7 would be the y-intercept for the parallel equation. Now, to present my final answer for number 4, an equation of a line parallel going through this particular point, and you can see that both equations have a slope of +3, as they should. They're two different lines because they go through the y-axis at two different spots. This equation goes through the y-axis at +4. This equation would go through the y-axis at -7. Let's look at number 5, same process, slope-intercept form. The only thing I need from the given equation is its slope, and I can see that in this equation the slope is -3. So just using the same process, I have an x and I have a y for my parallel equation. So first I can replace the m with the -3, and then I come back and I replace the x and the y, allowing me to easily solve for b. And then my equation for a line parallel to the given line, going through the point -1, -2, my final answer would be this. So these two lines are parallel to each other. They have the same slopes, and the line that I solved for would go through the y-axis at -5. The line that I started with goes through the y-axis at +5. Perpendicular slopes are opposite reciprocals. So looking at number 14 is a nice place to start. My given equation has a slope of +2. So that means a perpendicular equation would have a slope of -1/2. The product of the slopes of perpendicular lines is -1. So they're reciprocals and the opposite sign. The reciprocal of 2 is 1/2. Since 2 is positive, the slope of the perpendicular line takes the opposite sign, or negative. So the slope of the perpendicular line is -1/2. And the process is the same that I did before. All I need from the given equation is the slope, and I know that my new perpendicular line will have a slope of -1. I'm given a particular point with an x and a y. I let y be -1. X becomes 4, allowing me to easily solve for b. And I see that b is +1. So my equation for a perpendicular line would be this. And I compare my two. I see that my slopes are reciprocals of each other with opposite signs. The slope is positive, the slope is negative. And the two lines, you can graph them on your graphing calculator and view in your screen to see what it looks like when perpendicular lines intersect. Let's do number 17 together. Here's my given equation. My given slope is positive 1/4. So my perpendicular slope will be the reciprocal of 1/4. So my perpendicular slope will be 4/1. And since the given slope is positive, my perpendicular slope is negative. So setting up my equation, and then I'm given a new x and a y. And I find that b is 11. So the equation of a line that's perpendicular to the given equation in number 17 would look like this. And you can see that when I compare their slopes, they have opposite signs and they're reciprocals of each other. Okay, number 11 on page 53 is asking you to determine whether the three lines are parallel or perpendicular. So what I would do, I would look at each line and identify its slope. The slope in the first line is 2/3. The slope in the second line is 3/2. And then remember from standard form, an easy way to identify the slope, it's negative a over b. This equation is given in standard form. So the slope for the line I'll change to red. The slope for the line given in standard form, well, a is 2, b is negative 3. There's a negative sign built into the formula already, so my slope here becomes positive 2/3. Then when I analyze the slopes of all three lines that I'm working with, I see that the first equation and the third equation have the same slope, so therefore they're parallel to each other, parallel lines. And then moving to page 54, the geometry problem, number 25, you're given a sketch of a quadrilateral and the diagonals have been drawn in. So you have diagonal AC and BD. And you're asked to determine if the two diagonals are perpendicular to each other. The way you would prove that is by finding the slope of each line. So first you need to calculate the slope of AC, and then you need to find the slope of BD. And if their slopes are reciprocals of each other, and one's positive and one's negative, then you would conclude that the lines are perpendicular. So you need to look at the graph and identify the coordinate points for all 4 points, A, B, C, and D. And then you need to use the slope formula to determine if the two lines have opposite reciprocals for slopes.